Okay. Everybody hear me all right? Awesome. All right. Well, my name is Chip Johnson. I have been a part of the DevOps movement since about 2011, 2012. Over the years, I think this is somewhere in the 20s for me as far as DevOps days. And over the last 10 years, I've been speaking at conferences in LA, Austin, Santa Clara, Seattle, and Buffalo. And weirdly, not a one of the recordings has worked over the last 5. So I'm really hoping this one works out today. Anyway, I'm really pleased to be with you here today. So we're going to be talking today about guardrails, gatekeeping, and how to get business process into your delivery platforms. There we go. So here's my thesis. There we go. Sorry. I'm getting used to this. It's a little awkward. So over the next 30 minutes, we're going to be talking about the challenges in building an effective developer platform. We're going to be talking about how you can use policy guardrails to bring feedback from outside teams into those platforms without restricting flow. We're going to talk about things you need to keep in mind if you're going to do that. And finally, I'm going to have some concrete examples in here of how you can get different business rules embedded into your delivery process. That said, I'm going to be making some fairly broad assumptions in this talk based on the audience. First is that you are familiar with continuous integration, continuous delivery. Since you're here, I feel like that's a safe bet. I'm also going to be assuming that you're looking to adopt CI/CD or that you already have, right? And finally, if you're an advanced user, I'm going to be talking about ways that you can level up the value that you are bringing in to your company through these practices. So that said, here's our thesis statement. Developers move faster than process, right? And if the platform can't keep up, they're going to route around it. So over the years, I have been lucky to appear in a consulting role at a lot of different companies. And in all of those companies, I have found one of two things to be true. If they have multiple development teams, they are either in a state of expansion, where everybody is fed up with central IT. They are sick of slow process, slow builds, slow path to production. And there's a visionary off on one team who is like, I'm going to mess it all up. I'm going to adopt current best practice. I'm a visionary. I'm going to change it. Everybody's going to see how we can get to production faster without relying on those dinosaurs in the IT department. Or, yeah, there we go. Or they're in a state of contraction. They have hit the full explosion. And now they're saying, I can't move staff between teams because everybody ships in a different way. They're saying that it's taking too long to deliver some parts of the product while others are delivered instantaneously, and we can't make product release decisions anymore because we can't rely on anybody. We need to have one true path to production. I'm a visionary. I'm going to mess it all up and show everybody the way. And the best companies manage to do both of these simultaneously. They have the one path to production that is sold as a service to everybody else in the company. And then teams are free to opt into that or not, depending on what they want to do. And the really effective central services teams spend a lot of time talking to the other teams inside the business that aren't their customers and finding out why they're not customers. If there's a missing feature, if there's some sort of value delivery that they can do to bring them back into the fold. So when you are building an effective DevOps and platform engineering effort, Gene Kim and John Willis went ahead and gave you an ordered list of the problems you have to solve, the bottlenecks you're going to run into. I'm not going to sit here and read you the slide, but this is from Beyond the Phoenix Project, a talk track. Yeah, this is the one slide to photograph for sure. From Beyond the Phoenix Project, a talk track that they released as an audiobook actually in 2018, where they just break it down for you. But your platform's whole job is to solve all of these problems so that the bottleneck can be at ideas. The speed at which your development teams can come up with and implement new value for your customers, because that's really what it's all about, right? Anything that slows that down has to get dealt with. And every one of the past several DORA reports has some variation of this quote. I just happen to like the one from 2022 best. I know this is a big old wall of text, but your big takeaway, right, is that source control and a robust CI pipeline have to be at the heart of whatever you're doing for platform engineering. Those are the core technologies, and then everything you build comes on top of that. Again, I know this audience probably already knows that, but it's worth calling out, right? The data is really clear that these tools and everything you build on top of them, a well-built developer platform and a well-engineered DevOps movement, is going to amplify the productivity of every development team inside your company. And really where you're going here is developer self-service. If they're moving at the speed of ideas, if they're not thinking about how they get value to the customer, if they're thinking about what value they do deliver to the customer instead, then you are at the winning strategy. Developers are going to submit code to source repos. They're going to use the collaboration workflows they're already used to, like GitFlow or GitHub Flow. I hope nobody's on GitFlow, but and they're going to react to feedback in all of that same tooling, right? The common systems they're already using. And at that point, releasing features to customers is either automatic or it becomes a decision made by product and the rest of the business. But all of this, we are talking about technology, and there are lots of tools for doing technology-driven checks in your CI pipelines, right? There's linters, there's security scanners, there's dependency checks, there's licensing checks, there's code quality, you name it. But what do you do when the call is coming from outside the house, right? How are you going to handle it when non-technical teams like compliance, legal, and finance, they all need to have their say too, right? How are you going to take their feedback in effectively without introducing a new bottleneck? And the answer here is guardrails. Like we like to say, guardrails are lane assist. They're not stop signs. So how many people have been in the dreaded security backlog meeting? Show of hands. I hate this meeting. I've done this meeting so many times in my career. The security engineer shows up, you spend a couple hours, they shove you this big file of findings that are like, CVE with a number has been found here, it's got a score 10, here's the bundle of 6s that we don't expect you to actually fix. But here is your entire sprint backlog for the next 3 months, filled up resolving CVEs. And they're like, great, how do I solve those? I don't know, you got to go do the research. Like, this is on you. This is your problem, right? And it's slow, it's infuriating. You finish the meeting, and are you actually going to fix those CVEs? Like 1 or 2 maybe to appease the gods, and to put some plausible deniability on your back in case things get hacked. But what you're actually going to do is fix the things, ship the value that protects your bonus. You're not going to be worried about the security guy's bonus. Like, they can go take care of themselves, right? It's the worst, and everybody hates it. It's slow, it's brittle. You've just got a bunch of Jira issues that you're going to quietly close so they don't screw up your metrics. And everybody ignores it anyway. There isn't any clarity. It's just wasted time. So contrast that meeting, right, with what a debug statement looks like in your CI pipeline, just from a linter, for instance, right? You know what failed. You know where it failed. You could get at least a pointer as to why, if not the whole thing. And you kind of know what the rule is and what you've got to go change. And that's just from a linter. So wouldn't it be awesome if you could take all those security findings and give them the same kind of clarity, targeted research, the clear call to action, I know, product speak, and all the readability as you get from your linter failure? Like, when those rules change, wouldn't you like to just get that as a code update that's sitting in a repo where you can go review what changed, who changed it, and why? So this is the idea behind policy as code, and this is the idea behind using that to build up guardrails. Guardrails let you kill that terrible meeting forever by forcing this input to come in the form of structured data, right? Because what's a delivery pipeline except a bunch of rules about how value gets delivered? And the best part is this gets to be really fast because these rule evaluations happen sub-second. So I'm going to move from this into a couple of real-world examples, and then we'll get into considerations you need to bring to the table whenever you're building these things. And boy, I'm talking really fast. I am way ahead of my time whenever I was practicing this at home. So I'm going to try and slow it down a little bit. So we're going to move into some real-world examples. We're going to do it with a tool called CInspect. So CInspect project is about 4 years old now. I've been really privileged to work on it with some of the best colleagues from across my whole career. It comes with this massive library of content. It connects to damn near everything. And it's designed to effectively express your business needs as enforceable rules. So again, your policies, when I say that a policy describes a business need, with CInspec, our policies are structured YAML documents, right? You're going to have checks in a query language that are executed by CInspec using what are called providers. A provider is a plugin to a particular technology. Those checks, then they return pass-fail, and they return a severity score for a failure if there's a failure. And you can run it in any context you want. It's in Golang. It's really lightweight. You can bundle all the providers at once or just a single provider you need for the context where you're running. So you can actually do it as a Lambda if you want. You can run it as a daemon in the background of a virtual machine. You can run it as an ingress controller or an operator. You can remote in Ansible style over SSH. Really, it's just whatever context you need to run it and what makes sense for you. And of course, you can run it as a step in a build pipeline from a Docker image, right? I should definitely call that one out here. So a CInspec policy is going to describe all these different reasons and bring all this language together. Anybody who's sat in the technical side of a compliance audit, you're kind of familiar with how that conversation goes. For everybody else, what's going to happen is that the auditor shows up with this big list of requirements that are just vague enough you have to pay somebody to bring clarity to them. And those requirements are something like, they've got a number code to them, and then they say, ensure separation of duties in production environments. And then you sit down with the auditor and you define between the two of you what separation of duties in production environments actually means. Does this mean every process has its own user? Does this mean that devs can't log into prod? There's a whole bunch of different rules that could possibly mean this, right? And you all get together and you decide what it is, and everybody does the little dance, and then you sign off and your bosses sign off. And now you've got a rationale and you've got a rule that has to be enforced. But that context disappears really quickly as soon as you get out of the checklist. You just have like, why does nobody get to log into the prod database? I don't know, man. Compliance thing. Don't worry about it, right? And then 3 years from now, nobody works here. And maybe the compliance rule has changed, but nobody logs into the prod database. It might still be a good process, but you don't know. So CInspec lets you take all of that and express it into a YAML document with documentation. So when those rules run in the future, you've got the context about why that rule ever existed in the first place. So here's our first example. This is a security policy. This looks terrible on the monitor down here, but looks all right up there, I hope. So this security policy says we're not going to allow weak TLS versions in our endpoint. In this case, we're going to run CInspec anywhere we want to, really, but it's going to connect to the HTTPS endpoint served by our application, and it's going to validate that services are not live with deprecated SSL ciphers. So that's the whole thing, right? And we can go down, we can say, here's our title, here's our impact score. You can see the MQL, very GraphQL-like right there. And then we've got a description. Why are we doing this? Because weak SSL TLS versions leave us vulnerable to man-in-the-middle attacks, right? What's our remediation? I can't get as far as scripting remediation here because I can't swear that you're using Nginx over Apache. But we'll get into in a little bit how you can actually put in separate remediation for each context and provide documentation examples there if you want to do that. So contrast this with a typical Jira ticket that comes from security where they're just like, you're serving insecure ciphers, dude, go deal with it, right? So we don't have a security finding thrown over the wall that's just ops problem. Instead, we've got a finding and the research is done. We've got the exact service test, how it's failing, when it failed, why it matters, our score, and at least an idea of what we have to do to fix it. And when we have the output of the passing test, right, we can go back to security and show them evidence that we not only fixed the problem, but now it's part of our suite. So we're going to continuously test that from here on out and make sure it doesn't regress. And inevitably, as time marches forward and TLS 1.2 and 1.3 fall to the gods of increasing GPU counts, we will be able to update that rule to say now we need TLS future, right? Here's another example. This is a cost control policy, right? In this example, we're going to make sure that the GCP dev Redis instances aren't over-provisioned to save money on workload. Now, in this example, we're going to be using Terraform to build out GCP. And again, this isn't just the C-suite coming down and telling us, cut your cloud spend by 10%, yo. This is a targeted thing that we can bring back to them to say, we are taking direct action to cut cloud spend. And we can say, by cutting this cloud spend, we have had a measurable impact that we can report back. We can make our boss look good, right?
What?
And again, we're going to see that we get advice on which setting to change and how to change it. So we can run this policy, because this is in Terraform, we can run this policy at every stage of our Terraform execution pipeline. I can start this off as static analysis against my HCL source, right? You can see in here, I'm filtering against Terraform HCL. And then I am using Terraform provider in resource mode, which connects to HCL and does a SAS scan. And then I can run this again against the generated plan. And you can see we've got this variant that's going Terraform plan, resource changes, right? So it's a slightly different query, but it's still asserting the same thing. And then we can move it against our TF state and make sure that the generated state file reflects our intent. And say Google Redis instances, again, in dev, development, sandbox, and test are all using memory of 1 gig or less. And then finally, we can switch providers entirely and go inspect the production infrastructure and make sure that everything matches what we're asserting in our Terraform. So all the way across the entire life cycle here, we're going to be able to look at the generated GCP project and look every step of the way. And again, this whole set of checks is going to run. We're swapping providers, so I'm guessing 2-3 seconds. And when things go wrong, we're going to be able to embed a bit of documentation example of what the remediation needs to look like directly in the policy doc. So in this case, I've got a little bit of a code sample saying, hey, look for this kind of resource, a Google Redis instance, and look for the memory size setting, and pick that up, right? So I can say, here's where you go fix it in Terraform, so you can rerun and go fix it. And I can embed, you'll notice the remediation ID is Terraform there. I can drop in remediation document for as many platforms as makes sense. And it's just all documentation, right? So I can just make a new key and make that easy to look up. And of course, these policies are going to need to adapt to your business. You're going to have a bunch of different requirements depending on your life cycle. You're going to have logging, infrastructure, security, cost. And policy as code is going to let you represent all of those requirements as variables. So the same policy can get applied in different contexts and as a single source of truth. Like all of that 1 gigabyte in there in my examples, I hard-coded that for the purpose of this talk. But it's super easy to just replace that with a variable and shove it in. But now I'm talking about introducing a bunch of business rules into your build pipelines. And if that happens, you're going to need exceptions to those business rules. Okay, I guess I'll talk. Oh, no, good. Say, for example, the ML team is training up a new model, and they're going to need a GPU cluster in US East. But given the price of GPU clusters, you've just gone ahead and disallowed that as a blanket policy, and you got to wait for someone to come ask for it, right? And what's the thesis statement here? Developers move faster than process. Your platform can't keep up. They're going to route around it. And if you are using cost control as an excuse to stifle innovation, you're costing yourself a lot more money down the road by not having these awesome new features than you are saving right now, hopefully, right? So how do you make a good exception? A good exception needs to be time-bound, scoped, and regularly audited. Don't replicate your ticketing infrastructure to ask for exceptions. You're going to want to code up a GitHub bot. You're going to want it to live in GitLab where people do these things. When they see a failure, they're going to want to be when they see a build failure, they're going to want to be able to say, hey, request an exception for this time frame, for these reasons, and have it shipped off to an approver, right? You're going to want to record who approved it, how long it's been approved for, when it expires, and you're going to want to be clear about the consequences of falling back into violation. You're going to want to say like, hey, you're going to throw a warn from here out. You're going to fail to build entirely from here out. The finance department's going to come knock on your door. You got to know what's going to happen whenever that falls back out. And then you're also going to want to build feedback loops around this. You're going to want to measure what exceptions people are asking for and what policies are pinging most often. So for instance, right, say 40% of violations get tied to region not allowed. You've got a huge cluster around that. So you go talk to the people who are generating all these region not allowed violations, and you're finding out that dev builds are taking like 15 minutes for every commit, as long as they're happening over in US West. But turns out US East isn't that much more expensive. In US East, for whatever reason, they're finishing up in US East 2 in like 7-8 minutes instead of 15. Right? So you can adjust your policy to also allow builds to happen in US East. And now you've actually gone and saved a bunch of money when you thought your cost control policy was going to be saving you money, because that developer time is worth way more than a little bit of hike in your cloud bill. Right? So you can bring that down without significantly impacting your infrastructure costs. You're also going to want to know what's violating a lot, where are people asking for exceptions a lot, because it's going to mean that your policies aren't clear or that your policies are too strict in some way that's holding the business back. And when you've done that, when you find those in a regular review, you're going to want to go celebrate your wins, right? By adjusting this policy, we've cut our build times and developer wait time way down. We're able to ship so many more times a day. You're going to say, by putting this policy in place, we've cut our cloud spend by 10%. We have cut our MTTR for security defects in production by 10 days by having everything come in as a targeted failure in a test instead of just some Jira ticket shoved into our queue. Or the big one, right, where this can really pay off, we have shortened our audit cycle by months because every release gets checked against our audit criteria. So we can just show up with a pile of evidence whenever the auditor shows up. Because again, developers move faster than process, right? They're going to route around you if you can't keep up with them. And you wind up having a huge cultural impact here if you build this all up right. Because everybody's going to be aligned on the data. They're all going to be speaking the same language, right? Everybody's going to be using the same tooling to inject process into your business. Or they're going to be having the same meeting with you to take their requirement and turn it into language that can be enforced. We wind up with a shared responsibility because nobody's just shoving something in your queue and saying, hey man, your problem now. It's up to them to make sure that what they need can be expressed in a way where it can actually be enforced. And finally, you're not fighting each other anymore. It means that you guys can get out there and outcompete in the market and refocus your developers on shipping value to people, which is what really matters. And I'm a product manager, in case you haven't guessed by now. We ship value is like our whole deal, right? It does. So to wrap, I blew, oh no. That went way faster than I wanted. I missed my last slide. Last two slides. That's it. Can I get my last two slides back? We're done. Oh, okay. So wrapping up, right? No more gatekeeping, no more infighting. You don't wind up having that awful security meeting or those awful compliance meetings anymore. You got to have exceptions. It's got to be easy to make exceptions, track exceptions, handle those in a formalized way, notify people about them whenever they need to approve, notify people about them when they're about to expire. You're going to need to, when you start building up guardrails as a code base, you're going to want to put guardrails on your guardrails and get turtles all the way down. But treat those as product features, check them into a Git repo, manage them all as essential parts of your build process. And finally, you can get started with all of this with CInspect free today. There's other tools like OPA that can express these policies as well. The important thing is that you have a formalized language that everybody's landed on, that everyone will be using the same tooling to get this across. And my last slide, there we go. Anyway, so thank you. Here's my contact info. My favorite 7-year-old. If you guys want to get a hold of me, I'm real easy to find. I'm Chip at chipjohnson.com. I almost said .net, but I finally got the .com. After like 20 years of camping, it went for drop auction. I'm so stoked. And thanks for having me up here.